Alright, now let's solve using matrix inverses. So, going back to our analogy, if this was just a linear equation, I would multiply by the inverse of 2, which is 1/2 on both sides, and that gives me the 1/2 times 2 cancel out to just 1x, and then I get whatever I get on the right. So 1/2 times 10 is 5. Right? Or again, I would multiply by 5 over 3. Now it's important that we multiply on the same side, because which side you multiply in matrices actually matters. So that is an inverse, so it cancels out, gives me 1x. And this is cancels out and gives me 3 goes into that once, goes into that 5 times, gives me 25. So that solves a linear equation. What we're going to do for matrices is similar. So quickly, let's look at what happens if we multiply these. This is a 2 by 2, this is a 2 by 1, so my answer is a 2 by 1 matrix with the top entry being the top row times the first column. So top row times first column is right here, that's 1 times x, so it's 1x, plus 7 times y. Now that would just be numbers that we would simplify if they were numbers, but they're variables, so it stays like that. So when I multiply the bottom row by the first column, that gives me 2x minus 8y. Alright, so that almost looks like a system of equations, doesn't it? So we're going to use that fact, that this thing here, let me clean this up a little bit, 1x plus 7y, that 2 by 1 matrix could be written as 2 matrices multiplied. So you can go from that to that or backwards. So we use the property that if 2 matrices are equal, then each corresponding entry must be equal. So this can be written as 2 by 1 matrices, or an equation of 2 by 1 matrices. So x plus 7y over 2x minus 8y, that should look familiar, that's what we just did the page before, equals 0, 22. Alright. And we just said, based on the previous page, that this could be written as 1, 7, 2, negative 8 times the variables x, y to equal 0. Oops, not a line there. 22. Okay, awesome. Now what we want to do is solve this. So actually I'm going to give myself a little space here because of the next step I'm going to show you. So if we were to multiply those, that would give us 0, 22. But we want to find x and y. So what we're going to do is multiply by the matrix, inverse matrix of this. So whatever the inverse to this matrix is, that's what we're going to multiply by. And I don't actually show you how to compute them. You can do that for extra credit. Well, this product here is just a matrix times its inverse. So that's just going to simplify to 1, 0, 0, 1 times xy, which, that's the identity. So when I multiply that, it just gives me x and y. It doesn't change anything. So why even write it? I'm just going to write it as xy. And then that means that xy equals whatever we get when we multiply the inverse of the coefficient matrix times 0, 22. Oh, don't forget, it's the inverse. So we're going to let A equal this matrix. We're going to let this capital X just stand for our variables that we're missing. And B is going to equal the total numbers here. So what that tells us is, so now we can make it a little bit easier. Now our equation is just A times X equals B. Well, to solve a simple equation like this, we just multiply by A inverse on the left. That cancels out and gives us X, which is our variables, equals the inverse of matrix A on the left times B. So let's see how we do that on the calculator. It's pretty simple, actually. So we go into our matrix menu. We make a 2 by 2 matrix that represents A. So it's 1, 7, 2, negative 8. Just kidding. Oh, wrong negative. We got to use this little guy here. I'm trying to type it in on my keyboard. Alright, great. So then quit out, and we got to make a second matrix that stands for B. So I'll actually call it B in this example here. Just kidding. So over to edit, B, and that's going to be a 2 by 1, and that was 0 and 22, I think. I'm running off of my memory here. Great. So now what I'm going to do is select matrix A, and I want to do the inverse of that, so I just use the inverse key right here, right there. And then I'm going to multiply that by B. So again, go to matrix, select that one, and that gives me my answers. Sweet. So that means that x is 7 and y is 1. So what we just solved for was xy by doing A inverse B. We got this, so that means that xy equals 7, 1, negative 1. So x equals 7, y equals negative 1. That's the basic process for using systems, or using inverses to solve systems of equations. Now throughout this unit, I don't want you to use the RREF. I want you to use this other tool that I just taught you. Alright, so we have multiple tools that may accomplish the same task. So here are a couple examples for you to try. So you can go ahead and copy these down, use your calculator, do them. That's the answer you should get for the first one. Here's the answer you should get for the second one, and see you next class.